That skill presents rules of indices. When a number is multiplied by itself a certain number of times, we can write it in exponent form. So 3 times 3 is equal to 3 raised to the second power, also called 3 square. And 2 times 2 times 2 is equal to 2 raised to the third power, also called 2 cubed. The number that is multiplied with itself is called the base. So this is the base, 2 is the base. On this one, 3 is the base. And the number of times it multiplies with itself is called the exponent. So because there are 2 3's in this multiplication sentence, we have 2 on the top and it's called the exponent, also known as the power. On the second one, because 2 has been multiplied with itself 3 times, you see this 3 here. This indicates that the number 2, which is the base, has been multiplied with itself 3 times. So this is the exponent of the power. And when the power is 2, we call it a square. When the power is 3, we call it a cube. These are 2 special names you want to remember. You could also say raised to the second power, raised to the third power, raised to the fourth power, and so on. There are a few laws of exponents you want to know about. The laws of exponents, also called the rules of indices. And the first one tells us that if there is a base x and that's raised to the power of a, and that has been multiplied, so x raised to the a has been multiplied with x raised to the b, where a and b may be the same or different numbers. As long as the base is the same, x and x, you could combine them and rewrite that as x raised to the a plus b. Now why this works is pretty easy to understand. This one is a multiplication sentence in which x has been multiplied a number of times. So you have ax's, and on this one you have bx's. So if you multiply this with this, you have a plus b number of x's in all, which is written as x raised to the a plus b. In the same way, if x raised to the a is divided with x raised to the b, you have x raised to the a minus b. Remember, a fraction bar is nothing but a division. So essentially, we are dividing a number of x's with b number of x's, and some of the x's cross off from the numerator and the denominator, and in the end you are left with a minus b number of x's. And then if you have an exponent x raised to the a, and that itself has been raised to another exponent b, this is going to be equal to the same base x raised to the a multiplied with b. So the exponents are multiplied when an exponent has been raised to another exponent. Once again, it's pretty obvious. If you just open this up, you'll realize that this is essentially a number of x's multiplied with another a number of x's multiplied with another a number of x's, and how many times you do that is determined by this number b here. So if b is 3, you do x raised to the a times x raised to the a times x raised to the a. So you have 3 a's in the end, and reason why we multiply b with a. And then we have a couple of important derivations. If you look at this quotient formula here and set a is equal to b, which means the same number of x's on the top as on the bottom, and we know that when a number is divided with itself is always equal to 1, provided that number is not 0. So you cannot have 0 over 0, that's undefined. As long as x is not equal to 0, and if you set a is equal to b, this is going to be equal to 1. Now, if you set a is equal to b on this side, we have x raised to the a minus a, which is x raised to the 0. So here's an important derivation. X raised to the 0 is always going to be equal to 1 as long as x is not equal to 0. And in the same way now, if you set b to be a number that's larger than a, let's say a is 0 and b is, let's just keep it as b. So we have 1 over x raised to the b. The numerator becomes 1 the moment a is set to 0 because we just learned that x raised to the 0 is 1. So we have x raised to the a over x raised to the b. Set this equal to 0. So we have x raised to the 0 over x raised to the b. And we just learned that this is equal to 1. So 1 over x raised to the b is what we have. And that is equal to, if you apply the formula, this becomes x raised to the 0 minus b, which is x raised to the negative b. And that leads us to conclude that when we have a negative exponent, that's the same as the reciprocal of the exponent without the negative sign. Let's look at a couple of problems. Let's say we want to simplify 5 raised to the 4th times 5 raised to the 3rd. So this is going to be equal to 5 raised to the same base, different exponents, multiplication. So the exponents are going to be added. 5 raised to the 4 plus 3, which is 5 raised to the 7, which essentially means 5 being multiplied with itself 7 number of times. If we have 2 raised to the 7th divided by 2 raised to the 3rd. So this is going to be equal to 2 raised to the same base, different exponents, division 7 minus 3, which is 2 raised to the 4. So there was absolutely no need to find the numerical values of this and this. Here's another one. 3 raised to the 2nd, and that has been raised to the 4th. Now it's an exponent raised to another exponent on the base 3. So this time we are going to multiply the exponent. So this is going to be 3 raised to the 2 times 4, which is 3 raised to the 8.